Hello, everyone. This is Roger from the Google Open Source Security team. Today, I'm going to give a talk about the Transparency Logs 101, which will tell you how it can help secure open source and the internet. First of all, apologies for not being able to give the talk in person. I really want to come to Taipei to present this talk face-to-face in the conference. Thank you very much for all the audience attending this particular section.
好，欢迎来到这场议程哦。那我必须说，这场议程应该是各位这次 Costco 可以参加的英语，然后最没有压力的议程，因为我们讲者没有来。我们讲者因为那个健康因素，他现在在住院，所以他过来现场这样子，所以我们会播放他的预录影片，但是我们也会现场收集大家的提问，然后我们会要求他回答。对，还想逃啊？对，所以我们接下来会播放讲者的影片，然后他会跟我们介绍 Transparency Log 101 Securing Open Source Internet with Tessera， sorry， 好像 Tessera and TesseraCT. Okay, so if you have any questions, you can tell me, and we'll send it in batch to our speaker Roger. Okay, so we are going to play this with 哎，你好。它的 slide 会公开。对对，然后我们这个东西以后共笔也有，我们的那个议程表上已经有共笔。对，然后再就是这个影片接下来应该几周后应该也会公开在。也可以，也可以，当然可以。对，然后我们也会在几周后公开这个影片，就是有录影的，但是其实就跟播放影片一样。对，这样子。好，那还有问题吗？还有问题吗？还是你很想骂他？我可以。他现在在医院呢。对对对，就是对，好，可以吗？那我们要开始喽。
Let me introduce myself before we start. I'm a software engineer at Google Open Source Security Team based in London. I worked in Google Taipei for 1 year before moving to London. So I'm actually pretty familiar with Taipei. This is the photo taken in Google New Taipei City Banqiao office. My daily job is to write transparency log software. And of course, I will also operate the transparency logs, which I enjoy very much. Our team mission is to deter backed behavior by making it discoverable. I will show you how the transparency log works and how it fulfills our mission very soon. In this section, we are going to talk about the following items. First, transparency log basics. Why do we need transparency log? And how does it work? And then I will walk through a few real-world use cases. Next, I will also present our team's new solution, Tessera and TesseraCT, which is used for certificate transparency, of course, with a demo. Then the talk will end with the key takeaways. Let's talk about transparency log, which stores an accurate, immutable, and verifiable history of activity. So here are the benefits of transparency log. To echo what we have just said in the previous slide, accurate, the first benefit is that it discourages insider threats by increasing the transparency. The second benefit is about immutable. It simplifies the regulatory compliance. Imagine you are in a regulated industry and there is an auditor asking you to verify the integrity of your records. Then you can cryptographically prove that the records are not being modified by using transparency log. And then the third benefit is that we can monitor third-party ecosystems. For some ecosystems like certificate transparency, it is very important to monitor each logs to ensure there is no bad log operators. After we understand why transparency log is useful, I will show you how transparency log works. So transparency log makes use of verifiable data structure, Merkle tree, which is a binary tree with hash function. It is append only. Once you add an entry, it cannot be removed without being noticed. It is also verifiable by using cryptographic proofs. Verifier can check that an entry is in the tree. And when the tree is append, like if you add something to the tree, then you can prove that the trees are always consistent. So in this example, there are 4 entries, which could be anything, 1, 2, 3, 4. They could be binary or certificates. And then in this example, A, which is the hash of 1, and B, which is the hash of 2. And then if we go up a bit, C, which is the hash of A plus B, and then H is the hash of C plus G. So H is the root hash of this tree, of the Merkle tree. So this is how Merkle tree works. We make use of the hash function to hash each level. So next, we are going to make tiling a transparency log, which is like you are splitting the tree into tiles of a fixed height and width. For example, here is a permanent hash tree for the log with 8 records. So we are going to split them into multiple tiles, which is we can be represented as rectangle here. So here is how we tiled the log into rectangles. So we number them from left to right like this. N is the index of the tiles. Then we number them from the bottom to top. L is the level of the tiles, but not the tree level. And then we can actually represent this with a file system, which is very easy to store and serve with a local file system or a bucket style system like GCS or S3. So what we actually store in those files is the bottom layer of each rectangle. In this example, it would be ABDF in a file and then IJKL in another file in the tile folder. For the entries, of course, they would be 1, 2, 3, 4 in a file, and then 5, 6, 7, 8 in another file. So there are some community specifications for transparency log, and I will highlight 4 of them here. The first one is checkpoint. It is a common Merkle tree root representation. As you can see in the example, the first line is origin, which is an unique identifier of the log. The second line is the size of the log. The third line is the tree root hash, which is base64 encoded, and the remaining lines are optional. But in this example, this is a signature from the node. The next specification is witnessing. It is a protocol to protect against split view attacks. You may wonder what it is. Now, split view attack in this scenario can be a transparency log showing different log size and signature to different clients. Witnessing verifies and attests that the logs grows consistently. So if there is any split view attack, we will know. The third specification is tiles. I have already explained that in the previous slide. It is scalable and cheap to operate because the log data are static. So instead of storing them in a database, we can store them in a static file. The last specification I want to highlight is TesseraCT API. It is tailor-made for certificate transparency. It covers all the previous points 1, 2, 3, but it is still backward compatible with RFC 6962 with very little difference. If you're confused, don't worry. We'll get into certificate transparency into the next few slides. Next, we will quickly walk through each real-world use cases to show how transparency logs can be applied to different ecosystems. So the first one is open source software supply chain with Sigstore. Transparency log can be applied here. So Sigstore is like the Let's Encrypt for code signing. Sigstore automates the process of issuing short-lived certificates and use transparency logs to make all signing events publicly verifiable. from the flowchart here, we can see that a developer can get design certificates from Sigstore and then publish the signed artifact using that certificate. End user can then verify this signature of the download artifact to ensure the artifact is the right one before using it. And there is also a monitor here to monitor whether the transparency log is always consistent and it doesn't tell lie. So the next use case is Android Pixel binary transparency. So transparency log can also be used in Android Pixel firmware. Google maintains a transparency log with all published Pixel firmware. It is quite similar to what we saw in the previous Sigstore use case. Consumers, which means the Android user, can manually verify their Pixel firmware is in the log to ensure that they have the same firmware as others. And then here comes the certificate transparency. It is an ecosystem that makes issuance of website certificates transparent and verifiable. Basically, everyone, when you go to the internet, you are using certificate transparency. So when user contacts the domain over HTTPS, like when you use your browser to browse a website, you want to ensure that they are connected with the authentic domain owner. So user will get a certificate for this domain that proves the ownership of this domain. And there are policies, browser policies requiring all the TLS certificates. They need to be logged in the append only, public accessible, and verifiable data structure, which means the transparency log. So in this diagram, you can see for domain owners, when they want a new certificate, they have to request it from a certificate authority, CA, and then the CA needs to submit that certificate to the transparency log before returning it back to the domain owner. So there are actually many more transparency use cases like AI model transparency. You can store the model hashes, code commits, training parameters. For binary transparency, there are a lot of opportunities out there. Like Go modules, they have been using transparency log for a while already. And of course, we have already mentioned Android Pixel factory images. And transparency log can also be used in data access auditing. Like it provides the visibility when engineers get into your data. Transparency log can also be applied in private computing, key transparency like WhatsApp and iMessages. Yeah, and many more. If you got any use case, please feel free to come and talk to me. Now we are going to go into our new solution, Tessera, which is easy to operate and maintain, and there are catchability, and it returns static response. So Tessera is the next generation of transparency log. It is open source. It is available in beta, and it will be GA very soon. It is written in Go. The philosophy is simplicity, and there are multiple implementation storage. As you can see here, there are the supported platforms. They are POSIX, MySQL for on-premises. And then we also got some cloud platforms, AWS and GCP. For the Tessera, it is a library, it's not a binary. So you embed it in your own application, which is very, very simple. We got a lot of examples out there for you to follow. And here are the APIs like for write is actually very, very simple. You just need to call appender.add and then it will just work. And then for read, we make use of the C2SP tile specs, which is discussed previously, like how we tiled the transparency log. And for performance of Tessera, it can go from 1 to 8,000 QPS, depends on the backend and the money you got, of course. So it could be running, Tessera could be running on multiple servers, one server or even zero server like serverless. So let's try a demo. Let me show you a demo to see how it works. So first of all, we need to configure the log signing keys and the log storage directory. Next, we run the log. As you can see, the log initialized with the size 0. A checkpoint is also created. It is really, really easy to run a new transparency log. So after starting log, we can add something to the log. Like 1, 2, 3 here. And then we can check that the checkpoint is at the correct size, is size 3. Here is the application log of the transparency log. As you can see here, it goes from size 0 to size 3 for in the checkpoint, and the checkpoint is probably like every 10 seconds as configured at the moment. So the key takeaway is embrace transparency log to deter back behavior by making it discoverable. So come and talk to me about your transparency use cases. Thank you very much.
Test. Okay, so this is the end of the session because we can have our speakers in person here, and if you have any questions, you can write it down on our HackMD collaboration note, and we will send the questions in batch to our speakers.